Hey everybody, Mr. Elliott here. Last lesson of the semester. Let's just jump right into it. Called Quadratic Formula. Hey, if your initials are DT, I'm talking to you right now. I know it's the last lesson of the semester, but let's talk right now about building a good notebook. Part of building a good notebook is when you write notes to write the title of the lesson in your notebook. So for note takers out there, write quadratic formula here. Maybe put a big exclamation point so that you will be able to find this lesson in your notebook, especially if your initials are DT. Anyway, this lesson is all about the quadratic formula. In class, we talked about where the quadratic formula came from, but first thing we want to talk about now is when would we use the quadratic formula? Well, I kind of see three main instances of when to use the quadratic formula. I would definitely use the quadratic formula if it's not factorable. And that's, of course, if you also don't want to use completing the square. But when you get comfortable with quadratic formula, it goes really fast. Anyway, if it's not factorable, I always use quadratic formula. If the factoring looks really hard, I use the quadratic formula. If you're a bad factorer, quadratic formula is a good backdoor technique that will allow you to factor without actually knowing how to factor. So let's do three examples. The first example is going to be the not factorable variety. Number one. I guess before this we should put up here the formal quadratic formula is that if ax squared plus bx plus c is equal to 0, then x is equal to negative b plus or minus the square root of b squared. Then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Our quadratic formula. So I'm going to use this quadratic formula on my three examples. So example one, suppose I had x squared minus 3x plus 1 equals 0. Normally, I would try to factor this, but because it looks easy. You've got x's, you've got 1s, it's got to be an easy one to factor. But I need a number that multiplies to positive 1 yet adds, or I need two numbers that multiply to positive 1 yet add up to negative 3. Those two numbers don't exist, so you have to use quadratic formula. So my a is equal to 1, my b is equal to negative 3, my c is equal to 1, and then it goes x equals. It's wrong if you forget to put x equals here. Don't forget to put x equals here. Negative b, but b's negative 3, so it's positive 3, plus or minus the square root of b squared, negative 3 squared. Make sure you put your negative 3 in parentheses because so that both the 3 and the negative get squared, minus 4 times 1 times 1, a times c, all over 2 times 1. X equals 3 plus or minus the square root of, then we start going through our order of operations. Inside the square root is kind of like a parentheses, so we'll figure out inside the square root first. Negative 3 squared is 9. Negative 4 times 1 times 1 is negative 4, all over 2 times 1, which is 2. And my next step, I get 3 plus or minus the square root of 5 all over 2. And I don't know the square root of 5. And 5 as a square root can't get simplified, so this is actually my final answer. So that is quadratic formula when the problem's not factorable. Second reason, what if the factoring looks really hard? I mean really hard. And check out this example, number 2. 32x squared minus 36x minus 35 equals 0. I don't want to factor it. I don't want to try to factor it. I don't want to have to multiply 32 and 35. Those numbers are way too big. I'm just going to use quadratic formula. Factoring looks too hard. X equals negative b, so positive 36, plus or minus the square root of negative 36 quantity squared, minus 4 times 32 times negative 35, all over 2 times a, so 2 times 32. These problems, I normally tell you to not use your calculator if you can avoid it, but in this particular case, I don't know 36 squared off the top of my head, and I wouldn't expect you to. So 36 plus or minus the square root of 36 squared is 1296. The negative 4 times 32 times negative 35, so 4 times 32 times 35. And then I'm keeping track of positive or negative. It's a negative, there's two negatives in here, so it's going to end up being plus 4480 all over 2 times 32, which is 64. Next, x equals 36 plus or minus the square root of 1296 plus 4480. 5776 all over 64, and I bet this one actually has a clean square root. It does. 76, of course. So 36 plus or minus 76 all over 64. You'll never encounter a problem with numbers this large. I'm just trying to make an example of when the numbers are this large, it's still doable. I would break this into two separate equations. So you have 36 plus 76 over 64 and 36 minus 76 over 64. Let's see, when you add them, you get 112 over 64. Those are both divisible by 2. Well, they're both divisible by 4. 112 divided by 4, 25, 26, 27, 28. Oh, they're divisible by, oh, these are both divisible by 8. 14 times 8 is 112. So they're both divisible by 16. Is that right? 16 times 6? 16 times 6, that's 96. 6, okay. Oh, I don't want to cop out. Okay, I'm going to reduce with, I'm a pretty bad reducer. I'm not a bad reducer. I just do go part by part normally. 56 over 32 becomes 28 over 16 becomes 14 over 8, which becomes 7 over 4. So this is equal to 7 over 4, huh? I get that. Yeah, 16 times 7. There you go. All right, so 7 over 4 is my first answer. And then or 36 minus 76 is negative 40 over 64, and if you divide both of those by negative 8, yeah, negative 8, you get negative 5 over 8. So I have 7/4 or negative 5/8. Wow, that's an ugly answer. That's not that ugly. It actually worked out quite nicely. Anyway, this was factorable. By looking at this, you know that if you would have factored it, it could have factored into 4x minus 7 and 8x plus 5. Is that right? Yeah. So anyway, I wouldn't want to factor it. I would use quadratic formula for this. Example number 3. In example number 3, that was like, well, what if you're just a bad factorer in general? Example 3. 3x squared plus 5x equals 8. You want to make sure your equation set equal to 0 first, so I would use 3x squared plus 5x minus 8 equals 0. Now you can start working through your quadratic formula. Now this one is factorable. And if you're a decent factorer, it only takes a couple seconds to figure out it's factorable and get it factored and get a solution. But if you're a bad factorer, maybe you don't want to use it. You just want to use quadratic formula. -5 plus or minus the square root of 5 squared minus 4 times 3 times -8 all over 2 times a, so 2 times 3. Which gives me -5 plus or minus the square root of 25 plus -4 times negative, that's positive 32 times 6, so 96, so plus 96 all over 6. And then this becomes -5 plus or minus 121. And oh, you always get happy at this moment because you're like, nice, I know the square root of 121. It's 11. So -5 plus or minus 11 all over 6. So then you could break this into two statements. -5 plus 11, that's 6. 6 divided by 6 is 1. And -5 minus 11 is -16. -16 over 6, which reduces to -8/3. And you put an or between your two answers. And that's quadratic formula. For naysayers out there, like, I'm not really sure if I want to use quadratic formula or not. I just want to do, this isn't, the quadratic formula I've been using in these problems isn't normally how I just want to do one example showing you what Elliot normally does to solve these problems. And I'm actually going to use, I'll use the exact same one that I used in example 3. I'm just going to redo example 3, but I'm going to show you how Elliot does quadratic formula. So once again, we had 3x squared plus 5x minus 8 equals 0. X equals. Okay, this is what Elliot does. This is how Elliot talks his brain through this problem. And I'm going to start it. I'm going to time it. I'm going to start now. All right, -b, so -5 plus or minus the square root of b squared is 25. Then -4 times 3 is -12. -12 times -8 is positive 96. So plus 96 all over 2 times 3, which is 6. 25 plus 96, that adds up to 121. And the square root of 121 is 11. So -5 plus or minus 11 all over 6. And that's equal to -5 plus 11, which is 6, divided by 6 is positive 1, or -5 minus 11 is -16, so -16 over 6, which is -8/3, so positive 1 or -8/3. Boom, that was 53 seconds. So that was pretty fast. Could I solve it faster using factoring? I don't know. Let's find out. So 3x squared plus 5x minus 8 equals 0. All right, I'm going to start it now. All right, let's see. 3x and x. I know it's 3x and x equals 0. And then how would I multiply to 8? So it's either going to be -1 and 8 or -2 and 4. If I use 8, 8 and 3 add up to 5, so that's how it's going to work out. So I'm going to put the 8 here and the 1 here, and I want it to be positive 8 and -3, which means that the answer is positive 1 or -8/3. Bam! 32 seconds. So for good factorers, you could solve this problem in 32 seconds, whereas for quadratic formula, it took 53 seconds. So it's still actually pretty, it's pretty comparable. I guess the quadratic formula took me twice as long, but at the same time, I just added up 25 and 96 manually. So anyway, you can decide for yourself what technique you want to use. Quadratic formula definitely has its place. Sometimes I use it, sometimes I don't. It just depends on the scenario. Anyway, I hope you have yourself a beautiful rest of your weekend. Or if it's Monday, I hope you're having a great Monday. And I'll talk to you later. Bye-bye. Stop.